Hello and welcome to Learning Is Not Quiet presents Taxonomy, or classy people classifying. Today we're going to talk about different organisms, cute and terrifying animals, awesome and delicious plants, and very poisonous plants, and how we organize them, how we tell them apart. This is a very important part of science, is figuring out where things belong. And this kind of reminds me of a famous quote by one of my favorite chefs, Elton Brown, who says, "Organization will set you free." So if there's one thing you take away from this video, I hope it's that organization is important for science. It's also important for your home life, and it's scientifically proven that it will make things easier and better. And I'm going to prove it to you in this slideshow. Just as a brief note of housekeeping stuff before we get into the real science, parents and teachers, if you found this video on YouTube and are interested in purchasing the worksheet or activities that go with it, make sure you check out the links in the description. If you are a student who is doing this, make sure you pay attention to those words in all capital letters. They are usually a blank that you need to fill in on your paper worksheet or the answer to a question on your digital worksheet. So without further ado, let's get started, classy people. Let's get classifying. So the first thing we're going to talk about is why we should classify and what classification means. So a key word you need to know here is taxonomy. Taxonomy is the study of how organisms are classified, which might not sound as interesting as like being a vet and understanding, which medicines to give to an animal to make sure that they'll be fine. But taxonomy is the science that makes that science possible, right? We need to make sure that we're treating a chimpanzee as a chimpanzee and a gorilla as a gorilla. We need to know how these organisms are different and what makes them similar. Classifying means putting things into groups that make sense. There are over 2 million known species worldwide, and there could be from 5 to 10 million more that we haven't identified yet. And taxonomy is all about knowing more about the species that we already know and discovering new species. So now let's look at why this is important. Why we classify, and remember, organization will set you free. It is the key to life, I'm telling you. We classify organisms because, number one, it helps us figure out how closely related in the evolutionary tree organisms are to one another. So for example, even though I share some DNA in common with a banana, I'm much closer related to a chimpanzee than I am to a banana. We share much more DNA in common with a chimpanzee than a banana. And taxonomy helps me tell how far apart things are. That one's pretty obvious, but it might be harder to determine, is a bonobo closer to a human or is a gorilla closer to a human? For that, we need taxonomy. We need to see how things developed over time. Another useful part of taxonomy is it helps us keep track of organisms and helps scientists identify when new organisms have been discovered. It helps us find similarities and differences within these categories. So imagine for a second, you're an awesome scientist discovering to the rainforest, and you want to know if this new beetle you found is a new beetle or if it's something that's already been discovered before. How are you going to do that? You can try taking a selfie with the beetle. That will work, kind of. But the other scientists are going to want to know, where does this fit in the evolutionary tree? Can you prove it to me that you found a new beetle and it's not the same beetle that Joe Schmo scientist found last week with a different variation on it? And so taxonomy helps us discover the variations of those species, but also if we found a new species. Now let's talk about my man, Carl Linnaeus. He is a guy from the 1700s who first developed the scientific system that we use today of taxonomy. He was a botanist, or a scientist who works with plants, who decided that botanical names at the time were way too complicated. And here's an example. Thanks to him, a tomato is not Solanum, Calle, Inerme, Herbaceae, Follis, Pinnatus, Incissimus, Racemus, Simplicimus, but just tomato. He categorized over 11,000 species in his lifetime. Just take a minute to think about that. I don't think I have the patience to even count to 11,000. He categorized 11,000 species in his lifetime. So thanks to him, when you order a cheeseburger, you can say with extra or no tomato and not this whole, what is this? Solanum, Calle, Inerme, Herbaceae, Follis, Pinnatus, Incisus, Racemus, Simplicibus, whatever. Not saying that, just with or without tomato. So thank you, Carl Linnaeus. You make cheeseburgers better. So let's talk about the system surrounding taxonomy. Idea number 1. The system of classifying organisms is based on their physical characteristics. Get that in mind. It's on their physical characteristics. So let's take a look at one specific animal who's very cute. Her physical characteristics, she's a dog. She has 2 ears on the side of her head. She has 2 front-facing eyes. She has some pretty big teeth. Yeah, show off those teeth, Bruschetta. Show off those teeth. Yeah, she has a big tongue. Those are all physical characteristics. I can identify through taxonomy that this is a dog, specifically a pug within the species of domestic dog, and I can categorize her based on those physical characteristics. Her fur, her face, her ears, all of those things make up Bruschetta who she is, and it'll make me able to identify that she is a dog. So idea number 2. Some traits are evolutionarily more important than others. Before Linnaeus, all of these organisms, from birds to bees to butterflies to bats, were all classified together because they all had wings. But we know based on science that these have nothing to do with each other. They developed at the same parts. They all developed wings, but they didn't come from the same ancestor, right? Bats are mammals. They develop from other mammals. Bees and butterflies are insects, and birds are birds, right? They have wings, but for different reasons. And before this, they were classified together. 3, it follows a hierarchy or system that starts off really general and gets really specific. So you see in the general, it's eukaryotic. And in the eukaryotic domain, there's everything from mushrooms to the cardinal that you see there to plants. And then it gets more and more specific until we get all the way down to species. And it could only refer to that one species, Cardinalis cardinalis. And then finally, we still use almost the exact same categories Linnaeus developed hundreds of years ago. And I have a little chant that I like to use to help me remember this taxonomy. It goes, domain, you can repeat with me, domain, kingdom, phylum, class, order, kingdom, phylum, class, order, family, genus, species. And I know I have terrible dance moves, but you add your own better dance moves. We have domain, kingdom, phylum, class, order, family, genus, species. Thanks to all my students who have put up with my terrible dance moves for so many years. Okay, so let's talk about this system a little bit more carefully. So from general to specific, remember, we have domain, that's the most general, then kingdom, then phylum, then class, then order, then family, then genus, then species. Species is the most specific. So let's take a look at this with the example of my puppy Bruschetta. So she is in the domain of eukarya, right? She's a complicated animal, even though she still can't find the pee pad. She's in the kingdom of Animalia, right? She's an animal. She's in the phylum Chordata, and Chordata means that she has bones in her arms and legs and a backbone. She's a mammal, and I know that she's a mammal because she has all this lovely fur on her. She's in the order Carnivora because she's a carnivore, and I can show you that actually she has pretty sharp teeth. She doesn't like me touching her teeth, and she has forward-facing eyes, so those are some of the physical characteristics that tells me. She's in the genus Canis, the species Lupus, and the subspecies Familiaris. And so your dog, even if you don't have a pug, has those same classifications. She has variations on her that make her specifically a pug, even more subcategorized because dogs have very different characteristics, and that's a whole other lesson. But that's her classification. Domain, kingdom, phylum, class, order, family, genus, species. And you might have heard this, if chants don't work for you, you can also remember this with the acronym King Philip came over for good soup. Kingdom, phylum, class, order, family, genus, species. Binomial nomenclature is the 2-part name that gives the genus and species of an organism in Latin. So the binomial nomenclature for this puppy would be Canis lupus familiaris. Canis lupus familiaris. That's your binomial nomenclature. Isn't that pretty cool? Yeah. Moving on. Humans, important thing to know, we are all Homo sapiens. And sometimes students are surprised. They're like, there's no further classifications in it? Yeah, we're all the same species. So think about it. Whether you're a boy or a girl, have brown hair, have blonde hair, have dark skin, have light skin, we're all Homo sapiens. We all have that same binomial nomenclature. Thank you so much for joining me on this Classy People Classifying, all my fellow Homo sapiens. Thank you so much for joining. Remember that there are links in the description. Key things to take away from this lesson. Taxonomy is how we organize different species. We organize species because it helps us discover new ones, and it helps us trace their evolutionary path. The taxonomy was originally developed by Carl Linnaeus, the ultimate botanist organizer, and that system is still in use today. It's domain, kingdom, phylum, class, order, family, genus, species, and that's it. Thank you so much. Adios.